Adding and subtracting rational expressions. In this example, we're told to add or subtract as indicated. We have two rational expressions here that are being subtracted. When we look at rational expressions and adding or subtracting them, we should think about how we add or subtract fractions. In order to add or subtract fractions, we need common denominators. And if I take a look at these two denominators, they are already the same, c times the quantity c plus 4. To subtract these two rational expressions then, since they already have the same denominator, I simply subtract across the numerator. So this is going to become one rational expression with c times c plus 4 in the denominator, and then in the numerator we'll have c squared minus 3 minus, we're subtracting these two terms, so it needs to stay in parentheses, 5 minus 2c. And now it's a matter of simplifying. So in the numerator, I am going to distribute the negative to both terms. So I'm going to have across the numerator c squared minus 3 minus 5 plus 2c, all over that c times c plus 4. Notice that I didn't distribute the c in because we'd rather have our denominator, our expression, factored. To be factored is to be more simplified. So I'm going to leave my denominator. In the numerator, though, I can combine my like terms, negative 3 and negative 5. So in the numerator, I have c squared. I'm going to put the 2c next. I'm going to write this in standard form in descending power order. And the negative 3 minus 5 is negative 8. Again, all over that c times c plus 4. And then what we have to do is check and see if there's any more simplifying that I can do. So the denominator is already factored, and what I'd have to do is attempt to factor the numerator. So the numerator, c squared plus 2c minus 8, can be factored further. So the numerator can be factored to, we'll have c and c, that's how we make c squared, and the two numbers that multiply to give us negative 8 and add together to give us positive 2 are positive 4 and negative 2. So we're going to have plus 4 minus 2. And remember, we can check, so we get c squared minus 2c is outer, plus 4c is inner, so that would give us our plus 2c, and last would give us our minus 8. So remember, we put those positive 4 and negative 2 pieces in directly because the leading coefficient was 1. And now we have in the denominator our c times c plus 4. So now we have factors that can cancel. So c plus 4 over c plus 4 is simply 1. So we can cancel c plus 4 and c plus 4. Those become just 1. So what we have left is that 1 times c minus 2, well, that's just c minus 2, all over c. And this is as simplified as I can get. Remember, I cannot cancel this c and this c. They aren't factors. So I have c minus 2. These aren't being multiplied. So I'm not allowed to cancel the c and the c. So this is my final answer. Let's briefly go over the strategy for adding and subtracting rational expressions. First, if the rational expressions have common denominators, like the example we just did, we simply add or subtract the numerators and we keep the denominator. We combine our like terms, we factor, and we simplify. But if the rational expressions do not have common denominators, we have to factor the denominator completely and rewrite the expressions so that they share the least common denominator, just like regular fractions. And then we can add or subtract across the numerator, keep the LCD, and combine the like terms, factor, and simplify. Let's move on to another example. Here, add or subtract as indicated. We're going to add these two rational expressions, 5 over 8c cubed plus 13 over 6c squared. Since we don't have common denominators, we're going to have to start by finding the least common denominator between these two rational expressions. So we're going to focus on the number, the coefficient of each one first. So between 6 and 8, the least common denominator would be 24. That's the smallest number that 8 and 6 evenly divide into. So far our LCD is going to be 24, and that's not the entire LCD, but I'm just going to work with the coefficients first. So this rational expression so far, I'm just going to go ahead and write myself 2 fraction bars. So currently I have 5 over 8. So I'm just going to go ahead and talk about the coefficients for now. And over here I have 13 over 6. Well, if the LCD is 24, in order to make this denominator 24, I'm going to have to multiply by 3. But if I multiply by a 3 on the bottom, I have to multiply by a 3 on the top. And now over here, I want to make this denominator 24. So that means that I'm going to have to multiply this 6 by 4. And if I multiply the bottom by 4, I have to multiply the top by 4. And that's 4 over 4. It's like multiplying by 1. So we're not changing the problem. Same thing over here, 3 over 3. It's like multiplying by 1. So now these have the same denominator. 8 times 3 is 24. 6 times 4 is 24. And now we'll go ahead and focus on the variable part. So I have c cubed and c squared. So between c cubed and c squared, that least common denominator is going to be c cubed. So I take the variable to the highest power of the exponent that I see. So in this case, that's going to be c cubed. So I have 24 c cubed as the LCD. Now, the left side denominator already has c cubed. So that's going to stay exactly the same. I wouldn't put anything on the top because I didn't change the denominator at all. Over here, I had a c squared, but I need an additional copy of c. So if I multiply the denominator by c to end up with c cubed, I also have to multiply the numerator by c. And now these do have the exact same denominator. If I go ahead and multiply everything out, I have 15 over 24c cubed plus 13 times 4 is 52 times c all over 24c cubed. So now these have the same denominator. So that means that I can go ahead and just add across the numerator and keep that common denominator. So I'm going to end up with 15 plus 52c all over 24c cubed. And from here, there's nothing left I can simplify. In the numerator, I can't factor out anything. So nothing's in common between 15 and 52, and they both don't have the c in it. So there's nothing else I can factor, which means I can't cancel anything, because on the bottom I just have one term. So I'm not allowed to cancel these two terms, remember, because these are added. So there's nothing else I can do. This is my answer. In this example, we have x over the quantity x plus 4 minus 3 over the quantity 2x plus 1. This is slightly more complicated because we have binomials in the denominator this time, and they're not the same binomial. We have different denominators. So I want to go ahead and keep these in parentheses. I want to think about this as one whole binomial, another binomial. What I'm going to start out by doing is I'm going to rewrite this, but with a bigger fraction bar. So I have x over the quantity x plus 4 minus 3 over the quantity of 2x plus 1. And I need them to have the same denominator. So I'm going to start on the left-hand side. Well, the left-hand side has a copy of x plus 4, and I'm going to need it to have a copy of 2x plus 1 involved as well. So I'm going to need to put a copy of 2x plus 1 in parentheses in the denominator over here. And then I'm going to have to match it, multiply on the top by 2x plus 1. So now they're starting to look like the same denominator. So this one has an x plus 4, and now it has a 2x plus 1. But over here, this right-hand side only has a 2x plus 1 on the bottom. If they're going to match, if they're going to be the same denominator, the right side's going to need a copy of x plus 4. So I look over here and see, well, what's missing? What don't I have? And if I put it on the bottom, I have to match it with a copy of x plus 4 on the top. So in other words, the least common denominator here, the LCD, was simply multiplying the two denominators, x plus 4 times 2x plus 1. And now that they're the same on the bottom, the order is flipped, but that's okay because multiplication is commutative. Now that they're the same denominator, I can just go ahead and subtract across the numerator. So I can make this into one rational expression. So I'm going to put one big fraction bar here with the x plus 4, 2x plus 1 on the bottom. And on the top, I'm going to have my x times 2x plus 1 minus 3 times x plus 4. So I'm just writing that whole entire numerator part, so subtracted because the operation was subtraction. And from here, I'm going to go ahead and distribute the x, distribute the negative 3 in the numerator to both terms. So I'm going to go ahead and end up with 2x squared plus x minus 3x minus 12. So the negative 3 distributes to both terms, again over that common denominator, and I'm not going to multiply it out. So x plus 4 times 2x plus 1. In the numerator, I'm going to go ahead and combine these like terms here. So I'm going to go ahead and move this up a little bit to make myself some space. So I have 2x squared minus 2x minus 12 all over x plus 4 times 2x plus 1. All right, and then we have to check whether what we have can be factored further. So in the numerator, I can pull out a 2 from each term. That's the greatest common factor. So I'm going to continue to simplify. So if I take out the 2, I have 2 times x squared minus x minus 6 all over x plus 4 times 2x plus 1. And then I'm going to make a little bit more space here because the remaining trinomial does factor. So I can go ahead and leave the 2 on the outside, and I'm going to have an x and an x to multiply to get our x squared, and two numbers that multiply to give us negative 6 and add together to give us negative 1 are going to be a negative 3 and a positive 1. And then over my x plus 4 and my 2x plus 1 quantity. So we don't have any binomials that are going to cancel out. We don't have the same one on the top and on the bottom. So this is our final answer. So we had to check, we have to go through the process of trying to factor the remaining binomial or trinomial into binomials to see if anything cancels, and sometimes something will, sometimes it won't. So if nothing cancels, all of that is our final answer. In this example, we'll go ahead and subtract these two rational expressions, which do not have a common denominator. So this left-hand side, we're going to have to factor it before we can do anything. So we're going to have to factor out a d from the denominator. So I'm going to have d times d minus 8. So now what I'm going to go ahead and do is rewrite each of these with, again, that big fraction bar. So 15 and then over d times d minus 8. So I'm going to write the factored version though. And then minus 4 over d, but with that bigger fraction bar. Now here I want to make them have the same denominator, and they both already have a d in common. So this side has a d minus 8, so if I multiply this right-hand side by a d minus 8, then they'll have common denominators. But if I multiply the bottom by d minus 8, I have to multiply the top by d minus 8. And that's all we needed to do here. So the LCD here, the least common denominator, was d times d minus 8. So it only took multiplying one side by something on the top and the bottom. We don't necessarily have to do both. And now that they have the same denominator, we'll go ahead and combine this to be one rational expression. So one big fraction bar with d times d minus 8 on the bottom. And on the top, we're going to have 15 minus that 4 times d minus 8. And so we'll distribute across the top here, distribute in that negative 4. So we'll end up with 15 minus 4d plus 32 over d times d minus 8. And we'll combine those like terms, which are just the constants. So we'll end up with 47 minus 4d all over d times d minus 8. And we would check to see if there's anything that we can factor, because right now we have factored pieces on the bottom, but on the top we have terms that are subtracted. So we'd have to try to factor if we were going to try to cancel, but nothing can factor from 47 minus 4d. So that is my final answer. In this example, we want to subtract these two rational expressions. They don't have common denominators, so we'll need to start by factoring and making them have the same denominator. So n squared minus 36, that's the difference of squares, n squared minus 6 squared. So we'll rewrite this as n minus 6, n plus 6. And if I look over here, the denominator is 6 minus n, which is close, but it's not identical to n minus 6. So we talked about what we can do is 6 minus n is the same as negative n minus 6. If I think about distributing the negative back in, we can see that it's equivalent. If I distribute the negative in, I would get negative n, there's a negative n, and negative 1 times negative 6 is positive 6. So this denominator is really like negative n minus 6. And the negative there will cancel with this subtraction, because if I have minus a negative, it becomes addition. So I'm going to think about this minus being up here and changing this to addition. So remember that if I subtract a negative, we add the opposite. So it would be adding a positive. So the denominator on this side is really a positive n minus 6, but we changed the operation. It was subtraction, it changed to addition. So let's rewrite our problem now. Let's go ahead and put a big fraction bar. The top is 7n minus 30 on the left. The bottom is n minus 6, n plus 6. Then we have plus, so we're rewriting it with our addition symbol now. So plus n over n minus 6. So if I look to these two denominators here, this side has an n minus 6, so does this side. The left-hand side, though, has an n plus 6, so I'd have to match it on the right-hand side with an n plus 6, so I'd have to multiply by an n plus 6 on the bottom, and also multiply by an n plus 6 on the top, because that would cancel and give me 1, so I'm not changing the problem when I do that. So now they do have the same denominator, so we can add across the numerator. So we're going to go ahead and have, so one fraction now, one rational expression, n minus 6 and plus 6 is on the bottom. And on the top is 7n minus 30. And here, let's go ahead and start to make some of our work a little bit shorter. So we are distributing this positive n to each term here. So we are going to have plus n squared plus 6n. And then now we can combine our like terms in the numerator. So we have 7n and 6n. So this is going to become, in descending power order, we'll write n squared first plus 13n minus 30 over n minus 6 n plus 6. And then we have to try to factor the numerator. So we always have to try and see if here, once we end up with one rational expression, can we factor what's left and then potentially cancel a binomial or a term. So I have to see if there are two numbers that multiply together to give me negative 30 and add together to give me positive 13. So that does work out if we have an n and an n. That's the only way to get n squared. If we choose positive 15 and negative 2, that will work. So if I multiply outer, that's negative 2n, and inner is positive 15n. If you add those together, you do get your 13n. And then 15 and negative 2 multiplied gives you your negative 30. So the top does factor. The bottom is still n minus 6, n plus 6. So we had to check, but nothing cancels. So this is my final answer. And just to stay consistent, our LCD was n minus 6, n plus 6. So those two factors multiplied together were our LCD. This last example, we're subtracting these two rational expressions, but they have trinomials for denominators that are not the same trinomial. So we need to factor them first. So we have r and r. It's the only way we're going to get this r squared. And we're looking for two numbers that multiply to give us 16 and add together to give us 10. So those two numbers are going to be a positive 2 and a positive 8. So again, I can check. So r times r first is r squared, outer is 8r, and inner is 2r. Those add together to give me 10r. And last is 16. 2 times 8 is 16. We'll factor the other denominator. Again, we're going to have r and r. And the two numbers that multiply together to give me negative 40 and add to give me positive 3. Well, to get a negative number, one has to be negative and the other has to be positive. So we're going to need a negative and a positive. And the numbers are going to be 8 and 5. But the 8 has to be positive and the 5 has to be negative because we want them to add together, the negative 5 and the 8 to be positive 3. So we can check r times r is r squared. Outer is plus 8r. Inner is minus 5r. So that's going to give us our positive 3r. And last is going to give us our negative 40. So now these are our two denominators. We can see they're not the same. So we're going to go ahead and rewrite our two rational expressions. So 6r with their factored denominators. So over r plus 2, r plus 8, and then minus, we're going to have 3r plus 4 times my r minus 5, r plus 8. So now here, I need to make sure that they have the same denominator. So what I like to do in this case is I start to look at one denominator, the one on the left. It has an r plus 2 and an r plus 8. So I look over to the other denominator and I look for what does it have that mine doesn't. So it has an r minus 5. I want to take that. I want to copy it over. So I also want an r minus 5. And if I put one on the bottom, I have to go ahead and put one on the top. So that's it. That's the only thing it had that I didn't. So it had an r plus 8, but I already have that. Then I go to the right-hand denominator and I look at what does the other side have that I don't have. So I have an r minus 5, it does too. I have an r plus 8, it does as well. So what I need to include is an r plus 2. And if I put it on the bottom, I have to put it on the top. Now here's where we have to be careful. This 3r plus 4, that whole thing gets multiplied by r plus 2. So this needs to be in parentheses because it's going to need to distribute out. So now these do have common denominators. They have all the same factors. They're not in the same order, but that's okay. They have an r plus 2, they have an r plus 8, they have an r minus 5. So we can write this as one rational expression. So I'm going to put one big fraction bar here with the r plus 2, r plus 8, r minus 5 denominator. And across the top I'm going to go ahead and distribute in the 6r. So I have 6r squared minus 30r. So that's this left side, and then it's going to be minus, and I have to go ahead and completely distribute all of this out. So we have to do minus first. So I have in parentheses, I'm going to extend this fraction bar. So I have minus first 3r times r, that's 3r squared. Outer 3r times 2 is 6r. Inner is 4 times r, so plus 4r. And last is 4 times 2, so plus 8. Now let's go ahead and make some space and move this up a bit. So inside here I have like terms, so 6r plus 4r, that's 10r. So that's those two terms simplified. And this negative would distribute to all three terms. That's a common thing to forget because we're subtracting. So that negative goes to all of the terms over here, which was all of this multiplied out. So what we have is 6r squared minus 30r minus 3r squared minus 10r minus 8 after that distributing. And then all over, I have to keep writing that common denominator. Remember, we will not multiply that out. Once it's factored, factored is more simplified, so we don't want to undo that work and multiply it out. So we're going to combine our like terms. We have two sets of like terms. So we'll combine our 6r squared minus 3r squared, that's 3r squared. Our negative 30r and negative 10r is negative 40r minus 8. And then over that same denominator, it can get tedious, but we do have to keep writing all three parts of that denominator. And now, yep, we do have to try to factor this remaining trinomial because one of those factors might cancel with one of the three factors on the bottom. So here, let's go ahead and create our table to see if we can factor. Since the leading coefficient isn't 1, since it's a 3, we want to think about two numbers potentially that multiply to give us negative 24. So 3 times 8, so that multiply to give us negative 24, but that add to give us that middle term, negative 40. So if I try all my possibilities, so I'd have 24 and 1, 24 and negative 1, or negative 24 and 1, or 12 and negative 2, or negative 12 and 2. We could try 8 and negative 3, or negative 8 and 3. And then finally 6 and negative 4, or negative 6 and 4. None of those add together to be negative 40. There's no way that these numbers would add together to give us negative 40. So since there are no two terms that accomplish this, this numerator is prime. There's nothing more I can do, so this is my final answer. And one last time for consistency, what is the LCD? It's r plus 2, r plus 8, r minus 5. All of those factors multiplied together were my LCD.